Hello everybody. All right, we are going to go through the sample problems that we did in class on January 23rd. So here we go. So our problem is f of x equals 2 over 3x plus 4. And the directions are to find the inverse and then to use composition to verify it. So we're going to start with our step 1, which is to solve for x, which in case you forget means to get x alone on one side of your equation, on one side of your equal sign. All right, so we start by finding our x. We notice that we have a 2 over 3 multiplying times the x, and then we're adding a 4. We use the opposite of PEMDAS, right? The opposite order of PEMDAS. So usually we do parentheses first, exponents, then multiply or divide, then add or subtract. When we're moving things, we kind of do it backwards. We like undo it. So I'm going to add or subtract first. So I'm adding 4, so the opposite of that is to subtract 4. I subtract 4 to both sides. I'm going to change my f of x to y to make it simpler, and we get y minus 4 equals 2 over 3x. I did have a group today that was asking if it has to be y over 4. They said, can we do, what's the difference? Like, can we do y minus 4, or is it okay to do negative 4 plus y? So while mathematically these are both going to equal the same thing, y minus 4 is correct for a solution because in a different lesson we talked about, like, if you have 3x to the 4th plus 2x to the 7th minus 3 plus 6x squared, we have to put those in order from the variable with the highest exponent down to the constant. So because putting those in order would make this go 2x to the 7th plus 3x to the 4th plus 6x squared minus 3, that is why the y goes first and then the minus 4 goes second, because we do all of our variables first from highest exponent to least high exponent, and then the constant goes at the end. All right, so we've got y minus 4 equals 2/3 x. Now the last time we had a problem like this, we multiplied by 3 to get rid of the 2/3, but I would like to show you how to multiply by the reciprocal to get rid of it. So we're going to multiply by the reciprocal. Now I didn't put that in the steps because it depends on if you have a fraction by your variable, if you need to do that or not. But that's what we're going to do here. We're going to multiply times the reciprocal of 2/3. The reciprocal means that you flip your fraction. So the reciprocal would be 3 over 2. Now, why this is beautiful is because now we have a 2 on the top and a 2 on the bottom. Those cancel. That's 2 over 2, which is 1. Also, we have a 3 on the bottom and a 3 on the top, and in our denominator and our numerator. So that is 3 over 3, which is 1. So then we end up with just x equals, right? If that doesn't quite make sense to you, you also could have multiplied it out and gotten 6 over 6x, right? 2 times 3 is 6, 3 times 2 is 6, but 6 over 6 is 1, so you still get x. Now, on the other side, you do have to put parentheses around it and multiply this whole side by the 3 over 2, but that actually can be where you end that problem. Make sure you have your parentheses around your y minus 4. Step 2 is going to be to invert the variables. So in this case, we're going to invert the x and y. So that's going to be 3 over 2. Instead of y minus 4, it'll be x minus 4 equals, instead of x, it will be y. That's what we mean by trade or invert or switch the variables. And then this is one of our answer choices. So hang on, if you got something different, you might still be correct. But this is one way we can do it. All right. A more logical way would be that up here, you multiplied by 3 first because you didn't know about this reciprocal thing we could do. If you multiplied by 3 first, you would have gotten probably, sorry, let me make sure my colors match up or don't match up. You would have gotten 3y minus 4 equals 2x, and then you would have divided by 2 to everything, and you would have gotten 3y minus 4 all over 2 equals x. Then we invert our x and our y, so that would give us 3x minus 4. Holy cow, I'm doing it all wrong. It's 12. Sigh. This is my second time recording, so I'm going to deal with it. I'll start this over. So sorry. All right. So it should be 3y minus 12, because you're doing 3 times the y and 3 times the negative 4, all over 2 equals x. Then we're going to invert our x and y, so we get 3x minus 12 all over 2 equals y. And then this is a correct option for what your inverted function of f equals. All right, so if you got that, it is equally correct. One other way you could have done it as well would be if you thought you needed to distribute that 3 over 2 times everything inside. So 3 over 2 x minus, and then we'd have 3 over 2 times 4 over 1, and we'll have to figure that out. So we keep the 3 over 2x. 2 divided by 2 is 1. 4 divided by 2 equals 2. And then you still have to do 2 times 3 is 6. So we get minus 6. It would be 6 over 1, but we just switch it to 6. That equals y. So this is also an option for a correct answer for the f inverse of x. Now our biggest problem is going to be we have to choose one of these to work with when we're doing our checking, right? So this is where we draw our line, and we're going to check by composition. Composition was part 1 of our Module 7, Lesson 1. So we've practiced this a bit already. That's what our quiz was on. So let's go ahead and do this. So we're going to first compose f composed with the f inverse of x. And then we'll do it again using the f inverse composed, sorry for the G, composed with f. I'm going to rewrite that. There you go. Then we go to that page where we have our 14 different steps that we take to do composition. First, we start by writing the original problem. Our original problem was 2 over 3x plus 4. Then we're going to draw an arrow, and we're going to plug in one of our equations for our f inverse. So we have to choose which one we want to use. I think I'll use the orange one because I think that's how most of you would have done it. Maybe I'll choose a different one in a different example. So I'm going to use, I'll even do it in orange so we can kind of remember where I got it. So 3x minus 12 all over 2. And then that has to be in parentheses so we know it's going in for the whole x. Rewriting it, we get 2 over 3, 3x minus 12 all over 2 plus 4. Now, since the whole thing is over 2, I can cancel out those 2's, right? So that's beautiful. You're going away, you're going away. Why is it going away? Because 2 over 2 equals 1. And I have a 2 in the numerator and I have a 2 in the denominator. And we're multiplying. It only works if you're multiplying. And I see a 3 and I see this 3, but I cannot reduce or cancel those two unless I can also do it with the 12, which I can, but I don't expect us to see that easily yet. So let's rewrite it as we have it. 3x minus 12 all over, and we have this 3 on the bottom because the 2 became a 1. 3 times 1 is 3. Don't forget your plus 4. You could also know that this equals y. So now we have two options on how to solve here. We could go, hey, is there something I can take out on the top? And we could. We could take out a 3. We'd be left with x minus 4, and then the 3's would cancel. But I want to show you a different way because I think I showed you that way last time. So I'm going to do y equals, and then we can just separate and make sure that this 3 in the denominator goes under each term, and we can do it separately. So we'll have 3x over 3 minus 12 over 3 plus 4. And then the beauty here is that 3 over 3 is 1, so we get x equals minus 12 divided by 3, right? Because this is a division sign. Or you could think of it as 12 over 3 divided by 3 over 3 equals 4 over 1. So 3 goes into 3 once, 3 goes into 12 4 times. We get minus 4 plus 4. So then we get y equals x minus 0. So y equals x. Yay, exactly what we needed. Trying to get it to show, so sorry, give me a sec. There you go. All right, so we get x minus 0 because minus 4 plus 4, or it could be plus 0, same thing. Y equals x, yay. All right, then we do it again. Please pause here, see if you can do it without me. That is the main goal, is to be able to do it without help. Welcome back. So we start with the f inverse. So that means we need to choose one of our 3 boxes up here, either the pink, the blue, or the orange. Again, I'm going to go with the orange because I think that's how you guys would have done it, and I want to be as helpful as possible. So I'll use the orange pen again. So we've got 3x minus 12 all over 2. Then we draw our arrow, because for that x, I'm going to put in our original equation, which was 2 over 3x plus 4. And then I end my parentheses so I know that goes inside. Then I go ahead and transfer that so that they're all together. And we get 3 times 2 over 3x plus 4, end that parentheses, minus 12 all over 2. You might see that you've got a 12 and a 2 and you want to reduce that, but we cannot, because unless we separated it, then we could. If we split it up, then we could, but the way it is, we cannot. So I think what I'd like to do is to just do the whole top, see what I can do mathematically on the top, and then we'll divide by 2 at the end. So here, we are multiplying, so I see that I have a 3 on the top and a 3 on the bottom. And if you're like, Miss Heathcote, what do you mean on the top? It's not even anywhere, right? Well, this is a 3 over 1. So the 3 in the denominator and the 3 in the numerator equals 3 over 3, which is 1. So now we have 2x plus 4 minus 12. But I have to do that 3 times everything. So this 4 is not 4. It is plus 12. I'm going to write that again. 2x plus 12 minus 12. All right, we got to make sure we distribute times everything inside. And then this is all over 2. Plus 12 minus 12 is 0. So we have 2x over 2. 2 over 2 equals 1. So that means we have 1x, or we have just an x, which is exactly what we're going for. And that, my friends, is what you call a good hair day. or possibly too much caffeine. Who knows? All right, let's go to the next one. Here we go. Module 7, Lesson 1, Part 2. We're still working on inverse. And again, in class, everybody did these in groups around the room. So at home, you should really be trying to do them by yourself. And if you were in class for this today and you're just watching this for review, you should absolutely stop and see if you can do it by yourself, because that is the goal, not just to watch if I can do it, but to see if you can do it without me, without assistance, right? So our problem is g of x equals 9x minus 1/3. Step 1 is to solve for x. To get the x alone, we're going to add 1/3 to each side, and I'm going to change my g of x to a y. Y plus 1/3 equals 9x. The 9 is multiplying times the x, right? This means 9 times x. The opposite of multiplication is division, so I'm going to divide by 9. What you do to one side, you have to do the other. Now, I could do it to all the terms instead of just to both sides. I could do y divided by 9 plus 1/3 divided by 9, which if you see that, then I would suggest you do that in the future. If not, we can just keep going. This is beautiful because 9 and 9 become 1. We get x equals, and then here we have the y plus 1/3 all over 9. The problem is we cannot stop here because we can't have a fraction in a fraction, right? So here is where I would split it up, and I'm going to do y over 9, so that's the first term, plus 1/3 over 9 equals x. Now, I'm going to take this ugliness over here to the side and rewrite it. So we have 1/3, and then a fraction bar means divide, so divided by 9. Then you have to think back to 4th grade and how to divide by fractions, right? And so first, I like to make my whole number a fraction, so we go 9 over 1. And then we're going to keep the first fraction. We're going to change our division to multiplication, and then we're going to flip our second fraction. I would like to give you the Algebra 2 word for flip, please. We're going to write the reciprocal. Hello. Hi. So when you write the reciprocal, that's going to be, instead of a 9 over 1, it'll be a 1 over 9. So we've got 1/3, changing our multiplication to division, writing the reciprocal or flipping our second fraction. And then we just multiply straight across the top. 1 times 1 is 1. 3 times 9 is 27. And then if you use color in your notes, like circle that, and we're marking that we're putting that back in to our equation. So now we'll have y over 9 plus 1 over 27 equals x, which is allowed because now we don't have a fraction over a fraction. Step 2 is to invert our variables, which are x and y at the moment. So we get x over 9 plus 1 over 27 equals y instead of x. And then that is our inverted equation that we will use. And then we get to go check them, right? We check through composition. So I'm going to write check using composition. Composition is what we learned last week, so you're pretty good at this. I really see that most mistakes are made with our fractions. So the more practice you can get using fractions, the better off you'll be. So we'll start with our g composed of the g inverse of x, and then the second one we'll do will be the g inverse composed of the g of x. Start with our original equation, g of x equals 9x minus 1/3. Draw your arrow to say that we're going to use x over 9 plus 1 over 27. Put it in parentheses. Rewrite it with a y equals 9 times, and then in parentheses, x over 9 plus 1 over 27 minus 1/3. I hope you're like pausing a lot to stop and make predictions on what you would do next and how you would handle it, right? So here, we're going to distribute this 9 to both terms inside. Well, the beauty is that 9 on the bottom and 9 on the top, that gives us x, right? If you don't see that it's on the top, make it a fraction. Be careful crossing out your 9. You don't want to forget that you still have a 9 to multiply times 1 over 27. I'm going to write that part out, 9 over 1 times 1 over 27. And then we still have a minus 1/3. So here we can divide by 9 and get 1, and divide 27 by 9 and get 3. So we're going to get x plus 1/3 minus 1/3 plus 1/3 minus 1/3 is 0. So we get x plus 0, or we get y equals x, which is what we're going for. Nice job. All right, let's try it the other way. So now, and the reason we're checking the inverses is because eventually we're going to get ones that don't work, that are going to be like, oh, if you use 2, you end up with -1 equals 4. Well, -1 does not equal 4. So 2 cannot be one of your answer choices. So you just want to know how to do this checking part. All right, so we're going to start with the inverse first. So we get x over 9 plus 1 over 27. Then we draw our arrow. What am I going to plug in for x? My original. Our original was 9x minus 1/3. Now I rewrite my problem. Let's do 9x minus 1/3 all over 9 plus 1 over 27. Now I can see that I have a 9 and a 9. I would love for those to cancel out, but I can't do it because it doesn't cancel out with the 1/3. So let's separate it, right? Let's just do it the 9 under each term instead of under the whole section. So doing that, we would get 9x over 9 minus 1/3 over 9 plus 1 over 27. This part is beautiful because the 9 and the 9 create 1, so we get x. But this part is not allowed. So let's take that over here to the side, and we will do it write it out to do it. And we're going to keep that first one. We're going to change our division to multiplication, and then we're going to flip or write the reciprocal of the 9. You're like, Miss Heathcote, how can we write the reciprocal of the 9? It's not even a fraction. Well, let's make it a fraction. Let's make it over 1. And now it'll make sense when we flip it, right? So we'll get 1/3, keeping it the same. Change division to multiplication. Flip or write the reciprocal of the 9. We get 1/9. 1 times 1 is 1. 3 times 9 is 27. And then I'm circling that and drawing my line so I remember what I'm doing with it. I'm putting it back into our equation. So now I have x minus 1 over 27 plus 1 over 27. Well, minus 1/27th plus 1/27th is 0. So we get y equals x. Way to go. We'll give some long hair. This person looks angry. What happened to my smiley face? Whew. I'm not sure I'm making it better. All right, turn in the page. All right, I think this will be our last one. Oh, I think this will be our last one, and then I'll give you one you can try on your own that we will do in class next time I see you. All right. We're still in the same place. Module 7, Lesson 1, Part 2. I just feel one of the things you guys said you would like more of, or that would make you feel better about math, would be more practice, right? So that's the idea of this. The best practice is if you pause the video and try it on your own. Our problem this time is going to be h of x equals 3 over 4x minus 2. Step 1 is to solve for x. We do that by moving things away using the opposite operation. So we have minus 2, so we'll go plus 2 to both sides. Changing our h of x to a y plus 2 equals 3 over 4x. Again, I'm going to multiply by the reciprocal so I don't have to do 2 steps. This is beautiful because 3 over 3 is 1, 4 over 4 is 1, so we get x equals, and then 4 over 3y plus 2. Our second step is to invert the variables, or the x and the y. So I'm going to have 4 over 3, and then in the parentheses, x plus 2 equals y. So we have reversed them, right? And then this can go in a box because this is the inverse operation. Now you could have multiplied that out, maybe you distributed it, so you could have ended up with 4 over 3x plus 4 times 2 is 8, 8 over 3 equals y. That would also be correct. Doesn't even need the parentheses. It would be fine without them. There's one more way you could do it. You might also have gotten 4x plus 8 all over 3 equals y. That would also be correct, right? So or you just need one of them. Just need one of them. But if you're doing it by yourself, I don't want you to think you got it wrong if you just got it in a different form of simplification, you know? All right, and then let's check using composition. We're going to start with our original composed with our inverse. And then we're going to start with our inverse and compose it with our original. Please pause, try to set it up yourself. Welcome back. So we get h of x equals 3 over 4x minus 2. I just got that from, that's what they gave us as a problem, right? Now I'm going to draw my arrow to my x. Doesn't matter which one you use. I think I'm going to use the pink one just because I find it simpler. And I'd like you to start multiplying by the reciprocal so that you get the answer that way too. All right, so my x is going to be parentheses 4 over 3 parentheses x plus 2 closing parentheses closing parentheses. So I got to put all of that in for x. So here we go. 3 over 4x, and then I'm going to write all the pink. So 4, no, not the x, because this parentheses is becoming the x. I'm going to rewrite. 3 over 4, the parentheses become the x, so 4 over 3. times x plus 2, and then minus 2. Don't forget your minus 2 from the top, right? Now, because this is multiplication, I can go ahead and cancel those out already. If you didn't see that and you wanted to distribute the inside first, that would be fine, and it would still reduce, and you would still get the same answer. All right? So this is beautiful because we have a 3 over 3, which is 1, and a 4 over 4, which is 1, and that leaves us with x plus 2 minus 2. X plus 2 minus 2 is x plus 0, or just x, which is exactly what we're going for. I think I'm making my smiley faces too big so they look like faces. There we go. That's better. All right, then we do it again. Start with my h to the negative 1. So again, 4 over 3 times x plus 2 equals y. And then I'm going to draw an arrow, and I'm plugging in my original equation, which was 3 over 4x minus 2. Put that in parentheses. Now we rewrite it all. 4 over 3 parentheses. Now I write parentheses again for what I have in green. 3 over 4x minus 2. Then I still have the plus 2. And then I have the end of that parentheses. Okay. So here, I cannot just cancel this out because it's inside the parentheses with the negative 2. So I would either have to multiply this times everything, all 3 terms in the parentheses, or I could just subtract first. So there's nothing I can combine here, but then I can combine those 2. So we're going to go 4 over 3 times 3 over 4x minus 2 plus 2. Minus 2 plus 2 is 0. So now I get 4 over 3 times 3 over 4x, right? Because sitting next to the parentheses means we're multiplying. And then this is where it's beautiful, because the 3 in the denominator, 3 in the numerator equals 1. 4 in the numerator, 4 in the denominator equals 1. We are left with x. So we're going to do big eyelashes on this smiley face. There you go. Oh, can't even see it. All right. Then here's the problem to try on your own. Oops, it's in this book. Give me 2 seconds to find it. So sorry. I wish I could pause faster than I can. I should not find this sound so satisfying. Beautiful. It is going to be the function of x equals 3x plus 1. So the function of x equals 3x plus 1. We tried, some of our classes tried that on boards with partners today. That would be a great thing to try on your own before you come back to class. Have a great day.